This is part B of section 13.3, and we're going to talk about single replacement reactions in this part. First of all, in a single replacement reaction, we've got an element in a compound, and what happens is this element kicks out one of the elements of the compound, so it forms a new compound, different element. For example, a metal could be replacing a metal in this. A metal could be replacing hydrogen, and then a third thing that can happen is a nonmetal replaces a nonmetal. And I'll give you examples of each of those. First of all, let's talk about the metal replaces a metal. If this is a metal, A, it kicks out B. So B is over here by itself and forms a new compound, AC. Here's an example. Let's say you've got some zinc and you've got some copper nitrate, and this has to be in solution, but you put in a solid zinc, and what it'll do is the zinc is more active than this copper, and it will kick the copper out. So you see the copper ends up all by itself, and the zinc nitrate forms right here. Alright, so let's say that we just have the first half of the equation, and we know it's going to be a single replacement. We know that the aluminum is going to take the place of the metal. Metals take the place of metals. You gotta, it's always going to be that way unless it's a hydrogen. That's the only other one it can take the place of. So we're going to kick out the iron, and we're going to put the aluminum in that compound. You got to make sure, what the compound is going to be. Aluminum's a 3+, oxygen's a 2-. So we're going to get, if we do our little crisscross method, we're going to get Al2O3, and we're going to be left with some iron. And now this equation is not balanced, so we would have to put a 2 here and a 2 there to balance that. Alright, so why don't you stop the video and go ahead and fill these in. Okay, so in the first one, iron is going to replace copper. Iron can be 2+, and usually when they're replacing another one, if there's multiple, like iron could be 2 and 3, a lot of times they just stay whatever this one was. This was 2+ here, so it's going to replace that. So you're going to get FeSO4 plus Cu, and that's already balanced. Now on the next one you have to balance this, and it's not going to be the same because aluminum's a 3+ and it doesn't do anything else. And so with that, you're going to get AlCl3, and we're going to get some leftover copper. And now we have to go and balance it. Notice we got a 2 and a 3, so we're going to have to go to 6. So we'll put 2 and a 3 there. And then we've got to balance our coppers. We'll put a 3 over there, and our aluminums, and we're going to get that. Alright, another option is where a metal replaces hydrogen. So we've got, these would be acids, and so we're going to take and put some metal in an acid, and it's going to kick out the hydrogen. You get hydrogen gas and some other compound here. So for instance, if we take zinc and put it in hydrobromic acid, it's going to kick out the hydrogen. We get hydrogen gas. And make sure that you understand hydrogen is diatomic, so it's going to be H2. And we're going to get zinc chloride, and zinc's a 2+ charge, so it's going to be ZnCl2. Alright, so if we do this one with magnesium, we get a very similar thing. Magnesium and chlorine are going to go together, so magnesium is 2+, chlorine is minus, so we get MgCl2. We're going to get our hydrogen gas, and then always double check to make sure it's balanced. Make sure you've got all the same things. Alright, why don't you try these two? Stop the video and try that. Okay, so the first one, we're going to get zinc. Zinc's a 2+, and sulfate's a 2-, so it's just going to be ZnSO4 plus H2. Pretty easy. We get our hydrogen gas for that. On the next one, aluminum, once again, 3 plus, nitrate, 1 minus. So we're going to get Al, and then in parentheses, NO3, 3. And we're going to get some hydrogen gas. And now we've got to balance that. So let's see, we're going to have a little bit of an issue here when we try to balance this. Notice that we're going to need 3, but if I put a 3 here, that's not going to balance that. So let's just go right to 6. Let's just double that and say, hey, let's put a 2 there. That makes 6 nitrates, so let's put a 6 here. And I've got 6 hydrogens, so I need a 3 there. And aluminums, I need a 2. And make sure there's nothing that can reduce out. So 2, 6, 2, 3. We got an odd, so it's not going to reduce down. Alright, the third kind is where a nonmetal replaces a nonmetal. And what's important is as you do these, you have to figure out which of those 3 that we're talking about it is, because they're all just a little bit different. So here, and this usually happens with the halogen. So we've got chlorine, and it's going to take the place of iodine here. And notice that all the other ones we were replacing the cation. Now we're going to replace the anion in this example, or the one that comes second here. So the chlorine is going to kick out the iodine and form KCl, and we get I2. Alright, so on this one, once again, chlorine is going to kick out bromine. We're going to end up with NaCl. The bromine gets kicked out, and they're diatomic, so it's going to be Br2. And then we just need to make sure everything is balanced, so we better put some 2's in there to get that balanced. Alright, try these. We're just about done here. Give these a shot. Alright, so bromine is going to kick out iodine. We're going to get KBr. We're going to get I2. We need to put some 2's in to balance that. On the second one, they just kind of did it backwards, just kind of throw you off a little bit. You're going to get MgCl2 plus I2. Alright, that's the end of this part of the section. So, one more to go.